That's cool, Mr. Butter. Now we're back to stuff that everybody needs to know, and that everybody can know. We're on this part of the notes where it says, how do substances change phase? I wish this would keep on. I'm going to draw the particles at a particle view of a solid, a liquid, and a gas. I'm going to fly through these again, so be with us, be drawing. We've got a solid, a liquid, and a gas. Be careful when you draw these. I am going to draw them first. Pause, don't draw right away. Like, see how I space things out and see how I draw it. There are a couple common mistakes that students tend to make, and I want to make sure that you're not making them. So I'm going to be talking about like exactly what I'm drawing and why. I'm going to start by drawing the particles of the solid. Can you hear me now? Yes. Don't draw the particles too small, otherwise you're about to have to draw like 10 million particles, right? Don't draw them too big, because then you're not really being accurate. We're going to draw them kind of like a nice sort of medium-small size. And you'll notice in a solid, the particles are all going to be locked together in this sort of grid situation. They're all more or less touching each other. Wait, are they steady and not moving? Or are they vibrating?
They're vibrating.
Watch how I show vibration in my drawing. I'll take a particle and I'll give it like a little like vibration line next to it. Do you see that? And to me, that's how I show that they're vibrating. I draw the particle and I give it a little vibration line. And now they're vibrating in random directions, so I always kind of move my vibration line around. I'll be like, I'll put it over on this side now, and I'll put it on that side. And that, to me, looks like vibrating particles all locked together. This one, like, cut off the edge of there. So you can see they all kind of look like they're shaking, vibrating together. Good work. I see lots of folks drawing that really well. You'll notice all my particles are about the same size. That's important because I'm showing one pure substance. So each of the atoms would be like kind of the same. They'd look all the same. Next, what I'm going to do is I'm going to add heat. So I'm going to say heat is added as I go this way. So I'm going to add heat to this substance. Make sure you draw that line in there. I'm going to add heat going that way. And I'm going to see what happens. Okay, I got really specific about temperature just a minute ago, right? And now I said heat is added, but nobody asked me, okay, Mr. Boder, what exactly is heat? What is heat? Heat is, I'm actually going to define it right over here. Heat is the energy of random particle motion. Heat is the energy of that motion. Remember how we said Kane, when he's running towards the quarterback, there's kinetic energy in your motion? If we zoomed in and looked at particles, and they're vibrating, there's an energy in that vibration. And that's what we call heat. If I can increase the vibration of things, then I have given more heat energy into that substance. Everybody with me? Can you take your hands, clasp them together, and begin rubbing them? What do you feel happening?
They're getting hotter.
Why are they getting hotter? What is the friction causing the molecules to do?
Vibrate more.
You're actually rubbing the molecules against each other, and they're getting hit by each other, being like, ah, gah, gah, ah, and then they start vibrating more, and so then that is being hotter, because they're vibrating more. You mechanically cause them to vibrate more by just rubbing against them. Okay, we've got our solid. We're now going to add heat to that solid, and we're going to get it to melt into a liquid. Watch how the particles are arranged here. You've probably seen this. They're going to be the same size, right? But now they're going to be vibrating quite a bit more. And also, I'm going to try, this is really hard, but I'm going to try to draw them with like no pattern to how they are interacting together. So they're like flowing evenly around each other. They shouldn't be too spaced out, but they also shouldn't be like locked in a grid. It's really hard to draw, not having them end up being in a something like that. Try to draw them where they look like they're flowing around on each other. The interesting thing about a liquid is that the particles are vibrating, but now they have enough energy that they can't stay together. They can't be stuck together. They flow around each other freely. And that's what they're still attracted to each other. They're still held together by some intermolecular forces. If they weren't held together, they would float away as gas. They're still held together. They are stuck together, but now they can flow on each other. They have enough energy to do that. Next, we're going to add more heat. If I add more heat, that attraction that's holding them together is going to be broken. And they're going to have so much vibration energy that they're going to vibrate away from each other and shoot off into space. And that is going to be a gas. Watch how I draw the gas. I'll have a particle, and then I'm going to show it like bouncing off of the wall. Here, this particle is like going that way. This particle is like I'm shooting flying over here. These are speed lines, right? I'm only going to draw like 3 particles in there, because in a gas, they're very spaced out. They should be the same size particles as the other ones. Remember, all the particles in your substance should be the same size. This one got too small, didn't it? Just going to redraw that one. Here's a fun question. I have a solid here. There's little bits of spaces in between the molecules, right? What's in that space?
Nothing.
Nothing?
Wait, there's more stuff.
I've zoomed in to the smallest scale. I'm looking at the atoms. Are there smaller atoms in between the atoms?
No.
No, that's silly. Is there air in between the atoms? Well, air is made of atoms, right? It's made of particles. There's space. Empty space. Okay, wait. What about this liquid? The liquid is made of these particles. And I've zoomed in so that I can actually see the particles the liquid's made of. What's in between the particles? Space. Wait, let's go to gas. The gas is made of these particles that are flying around. What's in between the particles?
Oxygen.
Space. It's just space. There's nothing in between them. A lot of students will be like, they'll look at the particles and they'll be like, yeah, Mr. Boder, those are the particles, and then in between them is like air. No. Air is the particles. And in between the particles is just space. Just empty space. Which is crazy to get your head around. What we're flying through, when you feel air, when you feel like wind on you, you're moving the atoms out of the way. Like, atoms, get over there. These atoms here, good, get over there. And you're pushing the atoms around. And in between those atoms is just empty space. There's so many of the atoms that the air is here and we can breathe it, but there's empty space between them. Okay, sorry. Whew. Particulate level matter. Let's do a quick review. This is a review for you guys. When you take a liquid and you turn it into a gas, what do we call that? Shout it out.
Evaporation.
Or, what if we do it real fast on a hot plate? Boiling. The difference between evaporation and boiling is this. If you allow it to happen slowly, only on the surface, at ambient temperature, that's evaporation. If it's only happening from the surface of the liquid, that's evaporation. If you take the liquid and you heat it so that it's so hot that all throughout the column of the substance, molecules are trying to get into the gas form, all throughout the substance, that's boiling. Make sense? Evaporation was when it happens slowly just from the surface of the liquid. Boiling happens when you get the whole substance hot enough where it's all trying to happen at once. Okay, let's go the opposite way. When you take a gas and you turn it back into a liquid, what do we call that? Yeah, this is all a review from 8th grade. I have found that the 8th grade teachers do a fantastic job of teaching this, but I want to go over it one more time. What if we go from a liquid and we cool it down enough that it turns into a solid? What do we call that? Shout it out. Yeah, does it have to be cold to be freezing? Water tends to be cold when it freezes. That's an interesting thing about water. But what about, like, say, iron?
Very hot.
Can you have liquid iron?
Yes.
Yeah, it's got to be wicked hot, right? And then when you cool it down, does that liquid iron freeze at some point? Yeah, is it real cold when it freezes? No, it's still very hot. I don't know what the freezing point of iron is. It's like 900 degrees or something crazy. Yeah, it's real hot, but it still freezes. Let's go the other way. Let's take a solid and let's turn it into a liquid. What's that? You guys got it, melting. Again, the melting point of ice is like 32 Fahrenheit, 0 degrees Celsius. But the melting point of iron is, I don't know, 800, 900 something. It's really hot. Maybe hotter than that. I'm kind of guessing. These are the weird ones that are kind of fun. Did you know you can take a solid and turn it straight into a gas? What's that called? Sublimation. I heard it back there.
Oh, I had that down.
Sublimation. Have you seen dry ice? Dry ice is condensed carbon dioxide. It's solid carbon dioxide. Carbon dioxide does not like to be a solid at room temperature. It wants to become a gas. So it skips the liquid phase altogether and just like turns into a gas.
That's cool.
Yeah, it's awesome. Sublimation. It comes from the word sublime, which has to do with like ascending straight to heaven, like not passing go, just like becoming an angel immediately. So scientists were like, ooh, look at this stuff, it's solid, and it goes right to gas. It's like sublime, heavenly. So that's where they use that word. Let's go the other way. You know you can take a gas and like immediately turn it into a solid?
Yeah.
What's that called?
Deposition.
You got it. It deposits, deposition, the gas deposits into a solid. You've all actually seen this. Do you have a freezer at home? Is there any frost?